So here's our second trig review video, and I want to focus on how to find exact values of trig functions. So let's remember our chart with our quadrants, 1, 2, 3, and quadrant 4. We had our all-star trig class. Remember, this A meant that all of the trig functions were positive. S, our sine and its reciprocal function is positive. T for tangent and its reciprocal is positive. And C for cosine and its reciprocal is positive. So suppose we wanted to find the exact value of the sine of 2 pi over 3. Sometimes it's more helpful for us to know what this is in degrees so we can more easily identify which quadrant this falls in. So we can convert 2 pi over 3 times, since I want degrees, I'll put 180 on top. And so when I multiply these, my pi's cancel. 3 goes into 3 once, 3 goes into 180, 60. 2 times 60 gives me 120 degrees. And so I know sine of 2 pi over 3 is equivalent to sine of 120 degrees. Well, now I can easily see 120 degrees. Well, in my first quadrant, I go from 0 to 90. Second quadrant, 90 to 180. So 120 degrees lies somewhere in here, in the second quadrant, 120 degrees. And so to find the exact value of 120 degrees, it would be more helpful if I knew what its reference angle is. So the reference angle, remember, we always find with respect to the x-axis, this angle right here. If I know this whole thing is 180 and this piece is 120, so to identify my reference angle, I just take 180 degrees minus 120, and I get 60 degrees. So sine of 120 degrees, I'm in the second quadrant, sine is positive, so sine is positive, and my reference angle is 60 degrees. Well, 60 degrees, if I memorize my chart, my 30, 45, 60, 1, 2, 3, this equals positive radical 3 over 2. So this is what sine of 2 pi over 3 equals. Suppose I wanted to know the exact value of cosine of 2 pi over 3. Well, I did all the other work already. However, I know cosine in the second quadrant is negative because only sine and its reciprocal is positive. So this is equal to negative cosine of 60 degrees. Again, if I think of my chart, cosine is 3, 2, 1, so the answer is negative 1/2. Okay, so that's how we find exact values. I also wanted to go over number 5 on our worksheet today. Let's look at this example. For t is greater than 0, the position of a particle moving along the x-axis is given by, there's my position function. What is the acceleration of the particle at the point where the velocity is first equal to 0? So I have the position function. I know I need velocity and acceleration. Velocity function is equal to the derivative of the position function. So derivative of sine is cosine of t. Derivative of cosine is negative sine, so negative and a negative will give me positive. So I have my velocity function. I also need my acceleration, which is the derivative of velocity, so I'll take the derivative again. Derivative of cosine is negative sine, and derivative of sine is positive cosine. So now I have both functions that I need. Well, we're looking for the acceleration at the point where the velocity is first equal to 0. So let's look at our velocity function. cosine of t plus sine of t has to equal 0. Well, I could either subtract cosine or I can subtract sine. It doesn't really matter which I subtract, because what I'm looking for is where sine and cosine are equal but opposite signs. Where are they equal? I know if I go back to this chart, if I go back, I know they're both equal. They're both radical 2 over 2 at 45 degrees. They're both radical 2 over 2. So 45 degrees, well, we always start here, 3 o'clock position, 45 degrees in the first quadrant, but cosine is positive and sine is positive. This is up here. In the first quadrant, cosine and sine are both positive. I need to know where they're opposite signs and where this first happens. So I have to travel a little longer, go to the second quadrant. Well, second quadrant, sine is positive, cosine is negative. That's where the first have opposite signs. And so I'm looking in the second quadrant, where I have a reference angle of 45 degrees. So what is this angle here? Again, I'll do 180 minus 45 degrees. I get 135 degrees. So I know these two guys are equal and opposite signs when t is 135 degrees. But this is calculus. We don't want to use degrees. We want to convert this to radians. So if I want radians, remember, pi should be on top. Multiply that. Now I just reduce 135 over 180, and we get 3 pi over 4. And so this happens when t equals 3 pi over 4. So we solve the first one. Now we want to know the acceleration at this point. The acceleration at this point. So we're going to use that point and plug it into our acceleration. I want to know what is a of 3 pi over 4. So let's plug it in. Negative sine of 3 pi over 4 plus cosine of 3 pi over 4. Well, we already did the work. I know this is the second quadrant. Sine is positive. My reference angle is 45 degrees, so this is radical 2 over 2. My negative stays because this is positive. Cosine is negative in the second quadrant, so this will be negative. And I know 3 pi over 4. My reference angle is 45 degrees, so this is radical 2 over 2. So this is negative 2 radical 2 over 2, which just reduces to negative radical 7. This problem. A little blurry right now. I hope this helped.